Alrighty, so in this video here, we're first going to draw out and then solve for some of the values in the simplest circuit, and that is a circuit that has a single source. We use a DC voltage source to start, and then a single resistor. So this will be my circuit. I've got a DC source, and I've got a resistor here. And let's go ahead and say that this is a 12-volt battery, okay? Or a 12-volt voltage source. Doesn't necessarily need to be a battery, but that's typically what we like to think of as a power source. And let's say that I have a 100, wow, that one drew pretty thin, a 100 ohm resistor, okay? And so what I want to do here is I want to solve using Ohm's law. Well, what am I going to solve for? I'm going to solve for the current flowing through this resistor I. We're interested in knowing what is that current, and in order for there to be current flowing, I need a complete circuit. So I'm going to draw wires to connect my voltage source and my resistor. I won't always draw circuits so methodically and slowly. Typically, I won't even draw the connecting wires as a separate, element of the circuit. I'm just going to draw the circuit like I'll draw a voltage source and then a resistor just like this, and you'll just know that this and this are basically the same exact circuit. I just haven't drawn them element-wise. I didn't take the time to distinguish between the connecting wires and the elements. I just draw it all at once, and that's where we're going to get to. And so the last thing that I'm going to include in this circuit, because I'm not 100% sure how I would start if I'm a student, is I'm going to give you a little bit of a help, and I'm going to put a ground symbol right here. Okay? And so what we know is that we can use Ohm's law to solve this circuit. Oops. We can use Ohm's law, which I have written over here in the box, V equals IR. And we're going to go ahead and recall that the V in this equation is actually referring to the voltage drop or the voltage difference across my resistor. Okay? And so what we need to do is we need to label, let's label this side of the resistor V1 maybe, and the other side of the resistor we can label V2. And then in order to go ahead and solve this circuit for I, so let me rearrange this equation. V is equal to IR, so I could rearrange and I would get that I is equal to V over R, right? If I divide both sides by R. Okay, so now I know my R is 100 ohms. So I need to figure out my V, and that V is the difference in voltage across this resistor, which is V1 minus V2, okay? Well, if we remember correctly from some of the previous videos, we only have two nets in this circuit. And I'll go ahead and highlight them in two different colors. The first net is going to be this 12-volt net that's connected to the plus side of the battery. And the second net is going to be the ground net, okay? And so those are my two nets, and each net has an associated voltage, V1 in the green case and V2 in the purple case, okay? And so from the ground symbol, when we talked about the ground symbol, we know that symbol indicates that entire net is at 0 volts. So I can write that V2 is 0 volts, okay? And from the DC source video, we should recall that the indication of this 12-volt rating on my battery or my voltage source, it basically tells me that my plus side is 12 volts higher than my minus side, okay? So if my minus side is at 0 volts, then that means that my plus side has to be at 12 volts, okay? And again, since this is all one net right here, then that means that V1 is 12 volts, okay? So now if I have V1 and I have V2, I can say that V is equal to 12 volts minus 0, or V in my equation here. My V is going to be just 12 volts. Okay. In that case, I can go ahead and solve this circuit for the current that I was interested in, and I can say that my I is 12 volts divided by 100 ohms, or I is equal to 0.12 amps, which we would actually more regularly probably see as I would move this decimal 3 times, and I would say that I is equal to 120 milliamps. Okay, either are correct. This is correct, but you would just more typically probably see that written out as 120 milliamps. Okay, and so I've solved this circuit using Ohm's law. I'm sure there are plenty of questions, and so in the next video I'll solve a similar example, but I'll switch it up just a little bit.